the slides and the link to the video recording within the next few business days. Please monitor your junk inbox. Regarding the certificate of attendance, you will be provided a link towards the end. You'll be provided a link just prior to the Q&A section. There will be a QR code and the link for ease of access. This will take you to a survey to obtain the certificate. Please complete the survey. Please note that the certificate will be sent within the next 4 business days. Please note the business days are not inclusive of weekends. The EIT, the Engineering Institute of Technology, exists to bring engineers and engineering-minded people together. As one of the few institutions in the world focused solely on engineering, EIT offers both vocational and higher education programs and accredited by the Australian government, with many also recognised under the 3 international engineering accords. Our lecturers are industry experts, and our programs are designed to ensure graduates gain cutting-edge practical skills. EIT's unique delivery model is centered on student success. And then go to the next one. So ECST and ECT can be found on the screen at the moment. Sorry, just bear with me one moment. ECT delivers interactive and online UK qualifications, whereas ECST delivers South African accredited qualifications on campus. ECST is committed to providing students with world-class education, likewise with the ECT. You can learn more. I will provide information and links at the end. Just a quick disclaimer. The course and qualifications mentioned in this presentation are offered by separate legal entities operating in different jurisdictions, one in Australia, one in South Africa, and one in the United Kingdom. Each entity is subject to its own local regulatory requirements and accreditation standards. Prospective students should refer to the relevant institution's official website for accurate, up-to-date information specific to their locations, including the course availability, fees, regulatory status, and enrollment conditions. I will provide you a link to all of the different websites, so don't worry about that. Event conduct. So, essentially, we just want you to keep discussions lawful, respectful, and follow the monitor's directions. Do not share illegal or abusive content. Recording is not permitted unless authorized breaches may lead to removal. Sorry, that's unauthorized breaches. My apologies. So today we will be looking at, we'll be presenting the mysteries and paralleling. Paralleling, I hope I'm pronouncing that correctly, generators when 2 perfect machines refuse to share. Delivered by Professor Kalam, whom I will bring on the screen now. Thank you so much. And I will take myself off the screen. If you could take control, that would be perfect.
Thank you very much, Jasmine. Just give me 1 second. The screen is moving so fast, and I'm an old man. Have you given me the control, or?
You'll need to take control. So
I'm trying to. It's not allowing me. You need to give it. Yeah.
I think you have it.
I have it. So can you see I'm in slide number 9? Can you see that?
Yes.
Okay, good. So we'll come back to it. Good day to all of you. And thank you very much for coming again. A wonderful audience, wonderful uh, MC in the form of Jasmine. And it's great to see you in these mysteries, which has been always been very popular since the day we started. And good day to all of you from all part of the world. Today, what we are going to do is paralleling generators. When two perfect machines which are connected in parallel, they can't share. They refuse to share. That is the whole purpose of connecting the two machines in parallel, is so that they can share. And these two machines did not share. This is a very simple problem, my friends. It's not a huge problem. Two machines or two generators, both technically correct. There was nothing wrong with it, but they refused to share. They did not share the load. So the, the problem is that there's something you have learned in theory and there's something else in practice. And the twain are not talking to each other. What you have learned in the books and textbooks and lectures and other things is not what is happening in actual practice. So what we are trying to do is we are trying to uncover all these hidden assumptions and extract lessons from it, so that those who are the practicing power engineers do not have to go through the hard and learn it themselves. That's why these mysteries are such a beautiful idea that EIT has come up with. And when they asked me to start this program of mysteries, I was not 100% sure whether I'd be able to deliver the good or not. But as I kept on going ahead, I found these mysteries more mysterious than what I thought would be. So now the next thing is about myself, just to give you an idea that I am at EIT and work at different places too. I've got my consulting company. I work for the uh, as a consultant for the Electricity Supply Association of Australia and overseas. And I do a lot of administration work, because the change management plan for universities is one of the things that I excel in. Education wise, I have my initial degrees are from India, the Bachelor's of Science and then Bachelor of Engineering. It was a double degree. And after that, I had my uh, degree from United States, the master's, and the PhD from Bath in England. I'm a member of many of the associations, and I want to skip that slide because I don't want to waste too much time on it. Come back to the real stuff. And the agenda is there. Again, it's all there, the agenda. I don't want to read it. You can read it yourself. But we'll follow that agenda very closely. Now, uh, just wanted you to see this particular thing. And that is, if you look carefully, this is a modern power system, my friends. And in power systems, there are a lot of such type of synchronous generators, and they're all connected in parallel. And this is done so that there is no interruption. There's continuous parallel operation. So you find that we do not use one big generator. We don't use that. We use number of these small generators. The single large generator is outdated. So connect generators in parallel helps them stay in synchronism. adjusting their armature current and connecting them properly to the bus bar solves many synchronization issues. So when you have so many when you have so many alternators or synchronous generators which are connected in parallel, as you see, and this is connected to an infinite bus bar with a constant terminal voltage and a constant frequency and a very small synchronous impedance, the connection is known as parallel operation. I hope you understood what I said. I said there's a terminal voltage is constant, bus bar frequency is constant, impedance is very, very small. This is what is called this is what is called parallel operation. And when we are doing the parallel operation of alternators, we call it synchronizing. And synchronizing can be achieved in various methods, like synchronizing the lamp, synchronization of relays, synchronization of synchronous scope. Now, someone might ask, what is the advantage? And I'm just going through a bit of background. What is the advantage of this parallel operation of alternators? As I told you right in the beginning, continuity of supply. You know that even if it's 2 o'clock in the morning, there's a cricket match going in some obsolete place in the world. You want to watch it and you switch on the supply, you switch on your TV and you want to watch that cricket match. You The power company cannot say, hold on, it is midnight, I'm going sleeping, I'll come back and then I'll start the TV for you. No, you can't say that. On the flick of a finger, we want the power to come at all times. So we have continuity of supply and maintenance. We want efficiency. It gives you provision for expanding later on. It reduces the size of alternators and maximizes the power system reliability. That is why we do this in parallel. Now, coming to this, what we are trying to achieve, what we are trying to achieve, and I want to give you a bit of definition first. As I told you, when you talk about paralleling, you are involving number of DC generators to a continuous reliable power supply. The bus bar which is there is it is connecting the generators in parallel. So use that bus bar with positive and negative terminal. And the load sharing. These number of generators which is there are sharing that load. By adjusting the induced EMF, multiple generators can share the load equally and evenly. So I don't know whether uh, I see many names that have attended my presentation before, but I just want to repeat it for those people what I'm trying to do. I'm trying to tell you a story, my friends. This is not a normal lecture that you're used to. I'm trying to tell you a story. Lullaby, baby. Try and sleep, right? I don't want you to sleep, by the way, right? But I'm giving you that story. And I'm also trying to pretend someone whom I loved in the past and whom I saw so many movies of these people. I've never forgotten them. And I don't know whether they still exist or not. In my time, we used to have Inspector Colombo. I don't know whether you've heard about this name. Then I don't know if you have watched a film, not one film, number of series of that has come. Pink Panther. And those of you who have seen that would remember a very good friend of mine who is called Inspector Jacques Clouseau. That's not his real name, by the way. Inspector Jack Clouseau is actually Peter Sidler is his real name, but I'm just telling you the name in the film. Just like Columbo is not the Columbo's real name, his real name is Peter Falk. But these were my characters whom I loved. And that's what I'm trying to imitate. If you look at me and then watch at that movie, it will remind you of how stupid those characters look like. Exactly stupid like me. But it's a very nice story. I've always been absolutely glued to those stories, never missed a single series. That's what I'm trying to do. So I'm trying to be a forensic expert, one of those wonderful inspectors. I want to also become Sherlock Holmes, if possible, right? And I'm doing all that for I'm doing all that to make this story more viable and more involving you. So be very careful. So I'm trying to be one of those favorite guys of mine. And if you want to know why this story matters, is because generator paralleling is a solved theory. But you'll be surprised. The failures occur in modern plants too. Real system expose gaps, and the gap is between the math and the reality. You are absolutely brilliant. You are Einstein, you're Newton, right? In reality, your Einstein Newton theory does not work, my friends. So you, as postgraduates, as early career researchers, as early career people in the industry, those who have not got the experience, must learn beyond equations. And that's what I'm trying to tell you. And that's exactly what I'm trying to tell you. That you have to go beyond your equation, beyond the textbook that you have seen, because most of the textbook presented generator paralleling, and it said a straightforward thing. But in real life, you forget it is a system, and the system is combination of controls, sensors, human assumptions, and non-ideal hardware. And I don't know whether you realize this or not, but the biggest culprit in the power system or power station or where the power units are not the machines, are not the software, are not the hardware. The real problem is a human being. They are the ones, they do mistake and expect that the power systems operate properly. This is a beauty. And this particular case impresses me a lot because this is a practical problem I'm talking about. Nothing to do with theory. I don't want to talk about theory. I don't understand theory. I don't understand formula. I don't know that. I hate that thing. But I like my stories. And when you listen to me, you will never forget it in your life. I can assure you of that. So, my friends, I have got two machines, two synchronous generator. These are twins. It has same rating, same factory where it's manufactured, same commissioning procedures. So you, as an engineer, expected from day one everything to work perfectly fine. Because no problem. That's what you expected. So you had two synchronous generators, as I told you, same rating, same manufacturer, governors and exciters were identical. Very recently, it's not an old machine, brand new machine, right? And it was intended to work in parallel. So on paper, this was perfectly fine. There was nothing wrong with this, right, my friend? And this is what was expected, that the systems were synchronized perfectly. But what actually happened? Once connected, only one machine carried the load. The other one was a duffer. Attempts to force sharing caused oscillation and instability. One of them, say for 100 megawatt, was to be shared by two machines. One of them was taking all the load, and the other one was just sitting idle. So the load was not divided proportionally. So there was issue of stability. It could not reach stable operation. This actually happens. The prime mover input increased, that machine was overloaded. If that continued for a long time, it will blow up. And you can't afford to do that, my friends. So then what happens? What happens is I find I've introduced the problem to you, and just to make sure that you've understood what I have introduced, okay? This is what happened. Synchronization was not an issue. Breakers worked perfectly fine, but one of the generator took all the power. The other was zero. Adjustment made things worse. It's just like a group assignment that many of you do it. Okay. One is the one who's doing all the work. Okay. And there are three of you who are just sitting and let him or her do all the work. I've done this myself. When I was studying in the United States, I had one of my friend and she was very good in engineering. I let her do all the work, but I got D's and she got P's. This is the reality of life. Exactly in the same manner, things became from bad to worse because it started oscillation and instability came up. So, what was my reaction, my friends? Let us see my reactions. I mean, I'm an engineer. I've just joined in. Look at that. A young engineer just joined in. The first thought that goes, generator is faulty, man. Generator is faulty. Okay. Then I thought about, no, it's brand new. How can it be faulty? Ah, the tuning of the governor is bad. No, checked it. Nothing wrong. Wiring is bad. Wiring is bad. Nothing wrong with it. Instrument errors, operator mistake. All these thoughts came, and that person, that young person, was looking at it. All the thoughts that came in that person. This is the natural response, my friend. Hardware problem, software problem, people problem. But once when you do the initial check, you find that the software is perfect, hardware was perfect, and there was no mistake made by the operators. So my first reaction was definitely a failure. My first reaction was definitely a failure. Now, I just want to take you back to your undergraduate days when you were doing reactive and real power. As you know, it's a triangle. The base is real power. The perpendicular one is a reactive power. And the hypotenuse is the apparent power. That is why we call it S is equal to P plus JQ. And this is where the theory actually matters. I want to take you to that for a particular reason, my friends. A particular reason. I want you to see that real and reactive power are controlled by different mechanisms. And the confusion of the two creates a real problem. Real power is controlled by prime mover or governor. The reactive power is controlled by excitation, and sharing depends on the control. And unfortunately, the identical ratings and identical behavior are not similar. So let me go to the governor, and all of you have seen this particular graph that I've shown you. Drooping is a normal phenomena in machines, and it is not a flaw. It is done intentionally. This allows multiple machines to share load without fighting each other. You don't want them to start fighting. So the droop control, the droop characteristic that you see of the machine, if you look carefully of the droop that is there on the figure that I've shown you, you can see that that is very good. That is the one which is enabling load sharing. Without droop, I would have instability. And that slope is essential, my friend. That slope is essential. So then I see what is my hidden assumption. I want to give you the first lesson. Assumptions, I don't know whether you realize this, in particular in electrical engineering, when I was a student myself, we said that if you don't understand anything in electrical engineering with such an abstract subject, assume, assume. That's why there's so many assumptions in electrical engineering. So I say, assume that both the governors of that two machines, they had identical. Assume that the factory settings were equal. Assume they were of same model, therefore the response will be same. Uh, and there is no direct group verification performed. So you can see, if you look at that schematics, they failed spectacularly. So therefore, you saw that you didn't get much help in your in your um, in your theory that you have done in your universities and other institutions, right? So you say, okay, let me go to do some field measurements, and you start doing the field measurement. And if you did dynamic response, you would have seen subtle differences appearing. But if you did static values, you will not get anything. So look at that. You would do frequency versus power. You measured that. You looked at performing the load ramp test. You looked at individual generator response. You recorded all that, and you looked at any discrepancies that you can see. So, my friend, now you can see some discovery you have made. You can see that one of the two generators, say one of them say this is A and this is B, one of them drooped by 4% and the other one had 1% droop. If it is less than 4%, they're all within acceptable limit. There's no problem. But the problem is that as one of them drooped 4% and the other one drooped 1%, compatibility was not there. Can you understand that? Compatibility was not there, my friends. It failed to be compatible. Both governors met specification, but they were not the same specification. They were within limit. This mismatch that happened caused one unit to dominate. That is why generator A took all the load on his or her shoulder and left generator B to be just sitting idle. So the load was picked up. Now, someone might ask, why? Why one of the generator dominated? Why was that? Why was it dominated? remember that these generator, they've got controls. The generator which had tighter control effectively wins the frequency battle. So leaving other with nothing. Whoever has the control, even in the world today, whoever has control has the power, my friend. If you have control, you are Donald Trump. I can't give you a better example than that. So one of that generator became Donald Trump. There was a lower droop and stiffer speed control. A stiffer machine resists frequency change. It absorbs most of the real power changes, and the other machine just backs off. The other machine, which is sitting over there, just backs off and let Donald Trump do whatever they want to do. It's happening in real life. I'm just comparing my two machines with Donald Trump and whatever is the other person's name. So the other machine just backs off and let the dominating machine take control. And that's why one of them was taking all the control and one of them was taking all the load and not giving an opportunity for the other one to come. Now, as soon as that happens, and there's an operator in there, you'll find operator will trim the speed. And this is the type of synchronoscope they normally use. But that treats symptom, not the underlying control characteristic. You know, when you have headache, what do? You take a couple of Panadol or aspirin or something like that, isn't that? That's what you do, isn't it? Does it solve your headache problem? No, it does not solve your headache problem at all. It just switches off. It just switches off. Your headache is still there, but that control circuit which is in your brain switches off, and you think you have been cured. You have not been cured. This is typical characteristic. You see a temporary improvement, but the symptom seems to be less, and you think you are improving, but the actual cause of the headache is still there. So exactly in the same manner, when you adjust the speed, that doesn't help. Speed is bias shifts operating point. That's all it did. Just like that aspirin does not change droop slope. Didn't do anything with my headache. It temporarily gave me relief because it switched off the supply in my brain, and instability increased. As soon as the load started picking up, instability increased. So this is about real power, my friend. Now the question is, what happened in the reactive power? What about the reactive power? The same story is repeated again. But this is on the reactive side. Remember, one is P, which is horizontal, Q is perpendicular. Voltage regulators were absolutely perfect. You remember I told you identical machine, everything perfect. But they started fighting with each other. Okay. So reactive power sharing was also problematic. It was not only the real power, it's the reactive power is also having the same problem like my headache is causing. Exciter is set to the voltage control mode. There is no VAR, voltage ampere reactive is not there, and the droop is enabled. Circulating reactive currents is observed. That voltage regulators, which I thought was too perfect, they were started fighting with each other. So now I just want to spend a minute in explaining this circular current. My friends, My circulating current is exactly the way this person is being shocked. This is circulating current. Just touch it, my friend, you'll be like that. Okay? This is a silent killer, my friend. Nothing looks wrong until something overheats or trips. So there's a small voltage difference and the reactive current is large. And after a certain amount of current, it becomes deadly. It cannot deliver any useful load. Heating becomes very high and the system stability is reduced. So it goes to the unstable region. So although nothing looks wrong, there's overheating and tripping occurring. So now I've given you the problem. Now I want to see and try and understand what was the root cause? Where did I goof up? I don't think there was one single failure. I don't think. I don't think there was one thing. I don't know why I got the headache. I got the headache because Jasmine hit me the other day. Okay. So I got that headache because of Jasmine hitting me. I got headache because I could not sleep on that. That all that combined together, okay, gave me that headache. And my aspirin and Panadol did not fix the problem because there was a system of reason why I got the headache. Exactly in the same manner, the governor mismatched and they were drooping. There was no controlled, coordinated control philosophy. And we all dependent on what the factory has given. That what God has created, Akhtar Kalam. We just depended on that. And they knew that Akhtar Kalam will never have a headache in life till Jasmine hit me. So we were completely, did not do a system level testing. That is where the problem was. So it was not a single problem, it's not a single failure. This was a systems engineering problem. And it was not a component failure, my friends. So now we know the problem, we know the root cause. How do we fix it? We still need to run the two machines in parallel, isn't it? We want them both to share the load. That 100 megawatt, I want one of them to be sharing 50 megawatt, the other one to be sharing 50 megawatt, if you want a perfect world. The, the first thing I would do is standardize my droop setting. If one was 4%, the other should have been 4% also. Then look at the frequency power slopes. Retest under dynamic load and do a stable proportional sharing till that is achieved. So once the droop were matched, the problem disappears. Immediately, no more problem. It started sharing. So this is for the real power. Unfortunately, you have to do the same thing, my friends, for reactive power. The same thing you have to do for the reactive power. You have to do the same sharing. You have to look at the reactive sharing. And unfortunately, we as engineers only look at real power. We forget about the reactive power because that's an imaginary power, we say. You have to enable voltage droop or VAR control. You have to have a coordinated excitation settings. You have to reduce the circulating current. Remember the silent killer? And you have to restore the thermal rating or the margins. You will find reactive component which we have neglected is as critical for long-term reliability. So you cannot ignore it. Now, someone might ask, who's working in the industry, why is this happening so often? Why? Why am I getting this problem? Every time I'm getting this problem, why am I getting it? And this is in particular when we are commissioning it under no load condition. This is because we have tested the control systems in isolation. This is because we have thought in our mind that everything is within tolerance. It's a new machine. It's a new thing. Nothing can go wrong. Everything is perfect. This is because the interdisciplinary aspect, we have overlooked at it. And and this can be in any place, my friends. This can be in the ship, in the hospital, in data centers, in microgrids, you name it. Everywhere is a system thinking. So this is what I want to tell you. This is my crux of the story. Please try and understand. What is written in textbook is all ideal condition. I still remember when I was in my final year of engineering in the undergraduate program, I never knew that we could have single phase to earth fault. I always thought it's a balanced fault, it's a three phase to earth fault. Textbook always takes ideal cases. Real systems include tolerances. Control interactions dominate the behavior. Is more importantly, we always look at the label of the machine and we take it for gospel truth. It is not that. You have to do the measurements. So don't assume anything, my friends. You trust your data that you have got by doing actually the measurements. So now, what is the broader lesson that I learned? And this is normally the case with every student and everyone who has started the career in engineering. I want to become a perfect person. I want to become a superman, a supergirl, a superboy. Okay, no flaw in me. Everything is wrong with everyone else except me. I'm the best. Okay, and you will find that in order to be perfect, I do burnout, and instead of becoming good, I become worse because the conflict is from tightly controlled system. To improve stability, we must be flexible. Troop is a feature. Don't think that as a defect. And cooperation is much better. It's better to have cooperation because it overcomes precision. So, paradoxically, making machines less perfect often makes system more stable. Don't make it perfect, my friend. Every time I tell people, okay, I'm 95%, I'm happy. I don't want to become 100%. That's why I say, when you're doing your doctoral studies or some higher studies where you're doing research, intelligence, please don't use too much intelligence. 95% is hard work, 5% intelligence. I don't want too much hard work. I tell my PhD students think that I've flipped, which I have. And I tell them, look, please don't use intelligence. Please keep your intelligence to your home affair. Okay? Leave this intelligence out. Just use 5% of intelligence. 95% is hard work, my friend. 95% is hard work. So, and I'll be doing many mysteries because every month I'll be doing 2 mysteries. I don't know whether I'll do all this or not, but there's so many problems in life. This mystery that I talked to you today is not a unique thing. We can be talking about the same thing with UPS. It's uninterrupted power supply. They don't share. Parallel inverters, they started oscillating. Microgrids, which became unstable. Wind turbine, which was fighting the frequency. Two wind turbines fighting, my friends. These are some of the problems. And I'll be doing a lot of these problems. As I told you, every month I'm going to do 2. Okay. So this is not a unique problem, but this is the same pattern in modern power system and the same problem which every engineers face. And many of them do not know the answer to that. And you, as postgraduates, for those who are interested in higher studies, must remember one thing. Controls define behavior. Just matching the rating, looking at the nameplate on a machine is not enough. You have to measure the dynamic response. Ask this question, what assumption am I making? So this is what is the difference between an advanced engineer and a novice engineer. Is the question that they ask. Not just the formula, just mugging it up by heart, the formulas will not give you the solution. In the discussion that I want to discuss a bit, I'm just running short of time. I wanted to discuss with you, if instead of 2 generators, I had 3 generators, what would happen? I wanted you to participate. What if one of them was inverter based? Would isynchronous control help? Where would your instrument be first? I wanted you to tell me, but I want to encourage debate. But as the time is short, and my talks are a bit too long, but I will give you the answers so that you can think about it and think whether I'm right or your understanding is wrong. Because the more debate you do, the better. Uh, Mashuk, we'll talk about it, a difference between motor and generator in a minute. If there are 3 generators, that's the question I asked. And they're all connected in parallel, my friends, right? And they're connected to an infinite bus. Okay, that means there's synchronization where the voltage magnitude is matching, frequency is matching, phase angle, phase sequence, everything is same. Okay, the system becomes complex regarding stability and load sharing, but the system is exactly same. So nothing will change. It become complex, I understand, but nothing will change. Then my second question, what if one was inverter based? If one of these were inverter based, and you're finding more and more because there is so many solar panels you've got all these PV or battery system, the dynamic interaction changes significantly. You will have reduced inertia. You will have fast response. Your control strategy has to be different. You will have hybrid operation. Then, and I can debate on that for a long time. 1 hour would take me just to go for that second one. The third one, would isynchronous control help? No. The answer is no. Isynchronous control would likely be detrimental to parallel operation with an infinite bus. Group remember is necessary. I've told you right in the beginning. Asynchronous problems, right, which are there, if there are multiple generators like I've been talking about, okay, they will compete to take the load. This causes extreme load sharing instability, where one generator will take all the load while the others goes into reverse power and ultimately shut down. So when to use this? Your isynchronous control is designed for a single standalone generator or one that is sole master in an isolated, islanded system. So then my last question is the most simplest of them all. Where would you instrument first? Point of common coupling, PCC. The bus bar where the generators are parallel, I would do my instrumentation over there. So I've answered all the things that I wanted to discuss with you. I wanted you to participate. Unfortunately, due to time, I did it myself. My friends, what are the key takeaways today? Generator paralleling is a control problem, right? And this is my core message. This is a control problem. Group enables cooperation. It is not fighting one another. Identical machines are never identical. Never have to say, never say these are two instrument transformers. They're never identical. There will be some difference. Don't think in terms of component, think in terms of system. This is the core message that I leave you with. I want you to see this and understand that. And look, there's no doubt about it. You are an incredible person and you have so many things to offer, much more than my understanding, much more than what I can do. You people are much better. And I would like you to offer the world the real thing. Okay. And my last bit that I wanted to tell you is why this mystery is worth remembering. It's a simple problem. It was not a difficult problem, but it caused so many complexity. There were no alarms. There was no obvious fault. It required engineering brain and engineering judgment. And if you've learned a lesson, you will never forget it in your life. And I want you to understand, you will become an experienced engineer. Every experienced engineer will have a story. You will have many stories. This one just happens to be about generator. And I would like to end with a reflection. And my reflection that I want to do is that engineering is not a perfect path. Not at all. It's cooperative. You cooperate with the, I told you, system and system that is there. You understand? It's a system which is there. You have to cooperate with one another. And that is what the reflection. It is not formula, my friend. Just remembering P is equal to QV and E is equal to VI or whatever it is. P is equal to I square R. Remembering all that is not important if you cannot understand the system behind it. Now, question and answers, my friend. If there are any questions, I will leave it to Jasmine to control everything. But before she takes over, I just want to tell you my next seminar will be next time, will be on next week. Next Thursday, there will be a seminar again, which we'll be talking about one of the issues, other issues. But I've got a whole list, and you can find that the list in the website itself. This is the April one. You see, every month I've got two. March, I've done the first one of the mystery. The second one I'll do the next time on next week. And I've got every month, I've got two issues. I hope you've enjoyed my presentation. But I leave the question and answer session and all the control to the boss, Jasmine.
What I've done, we'll just go back to the Q&A section. I've just copied and pasted everyone's questions in the chat. So if you have a look there, you'll be able to see them. I'll leave you on screen.
I will definitely do that. Okay. Oh gosh, this is there's many. This is initially just the issue that they were having to join the webinar. Someone is asking, increase more zoom on the presentation, please. So that is not my problem.
No, just scroll down.
That is just okay. And
it'll be a really long message with a lot of questions. Alternatively, I can send it to you in private message, whatever works best for you.
What is the difference between an alternator and generator? Not much. It's exactly the same thing. Okay, just the direction of the current. The same question has been asked by someone else, I thought. Is it possible to share some doubt? Oh, I've been having troubleshooting alarm on LCD display on my generator. When we turn on one of them, they're linked on parallel and give low frequency. And Jen said, start run, but on a minute turn off. Why this is happening? It's a very simple thing. There is a difference in time between the linking and the parallel thing. There's nothing wrong with it. The machine will absolutely work perfectly, even if it's a 50 hertz supply and you are getting 48 hertz. So just a question of a time delay, which is there. And maybe it's been done that. What is hunting in a generator? This is not hunting like shooting a duck or something like that. Okay, hunting is a hunting of a machine. It goes to subsynchronous resonance phase, and that's what is called hunting. Then a question is asked. Where generator is initially synchronized automatic, but it failed to synchronize shell load and all, while manual synchronization will work, I think. The problem is not that. The problem is to find the right type of operators to bring it to a manual condition. And it could be any reason. I told you it's a system problem. It could be due to AVR. It could be due to governor. It could be due to synchronization. It could be due to the control logic. I told you the most important criminal is that control logic. That's more of a problem in synchronization than anything else. But the others can play a part. Then what is the difference between motor and generator? Very simple. One current goes this way, the other current goes that way. That's all. It's the same machine. No difference. No difference whatever. It's a flow of direction of current. One is drawing, the other is giving. The same machine. What happens if the generator is overloaded? If the generator is overloaded and it keeps on going on for the lifetime, you will find that they will die much faster than what is there. It's just like me, I'm a donkey and EIT is loading me every time and I will die very quickly. I think I was going to live another 20 years, but the way they are asking me to work, I'm going to die. This generator, a poor generator, Mashuk, is going to die too, okay, because it's overloaded. It will work though. What is the difference between, I've already told you. What is the hunting I've already given you? I've given you the answer. 4% is the standard group. I've covered all the questions.
That's phenomenal. Thank you so much, sir.
It's right on time, Jasmine. Don't complain that I did not do it in time.
No, you've done amazing. You've done amazing. Absolutely. As Professor previously mentioned, we have some amazing upcoming mystery webinars, so keep an eye out for that. I will provide you a link for ease of access as well. Thank you to all of you for joining in today's webinar. It was a really good turnout, which is phenomenal. Moving forward, so we have some amazing upcoming courses surrounding this topic, which is fantastic. This is for EIT at the moment. Just take a read through those when you get a chance. Then some more upcoming courses for ECT and ECST. Then, just one moment, please. Copy. Fantastic. And now, the moment you've all been waiting for, the certificate of attendance link. I will have provided it with many other links as well, and inclusive of my own, I was about to say personal email, but it's actually my professional email. It's my course advisor email, to be specific. So please do reach out if you have any questions about any courses or you need any assistance with anything. You're more than welcome to utilize the QR code as well. The slides will be provided in approximately 2 business days. Please keep an eye out for that in your junk inbox as well. As you can see as well in those links, I've provided a link for EIT, ECT, and ECST. Please feel free to look through the different websites. They are different, and make sure that you are looking at the correct information for the correct course. I believe that comes to our conclusion for today. I would like to thank Professor Kalam. I really appreciated the phenomenal presentation, as always. And thank you all again. I will now stop the recording. Wonderful.
Thank you.